Have you ever sat in the quiet corner of a garden and watched a colony of ants moving in a perfect line across the earth? They are busy, focused, driven by chemical signals and ancient instincts that tell them exactly what to do. They build complex structures, they wage wars, they gather food, and they care for their young. To the ant, that patch of dirt and grass is the entire universe. It is everything that matters. But you are there, towering above them. You are watching them. You understand their world in a way they cannot possibly comprehend. You know about the rain that is coming later that afternoon. You know about the lawnmower that will pass by tomorrow. You know about the vast city that surrounds the garden and the planet that spins beneath it. The ants do not know you are there. To them, you are just a force of nature, or perhaps you are simply invisible, existing on a scale so large and so different from their own that their senses cannot even register your presence. Now, I want you to close your eyes for a moment and let your breath slow down. Imagine that we are the ants. Imagine that our Earth, this beautiful blue marble floating in the dark, is just a small patch of soil in a much larger garden. And imagine that someone is watching. This is not a frightening thought, or at least it does not have to be. It is a thought that invites us to look at our universe with a new kind of wonder. It asks us to consider the possibility that the silence of the cosmos is not empty, but rather that it is a respectful silence. A silence maintained by observers who are waiting, watching, and perhaps gently guiding us in ways we are only just beginning to imagine. This is the story of the zoo hypothesis, the scientific possibility that we are part of a cosmic experiment or a protected sanctuary. But before we can understand why someone would watch us, we must first understand the stage upon which this experiment is taking place. We must understand the sheer, overwhelming scale of the possibilities. When we look up at the night sky on a clear, dark night, away from the city lights, we see a few thousand stars. It feels like a lot. It feels like a canopy of diamonds stretched over our heads. But what we see with our naked eyes is less than a fraction of a percent of what is actually there. Our home galaxy, the Milky Way, is a barred spiral galaxy that stretches across 100,000 light years. It is a city of stars so vast that a beam of light traveling at 186,000 miles per second would take 100 millennia to cross it. Inside this galactic city, astronomers estimate there are between 100 billion and 400 billion stars. Let that number settle in your mind. 400 billion suns. If you were to count them, 1 star per second, without sleeping or eating, it would take you more than 12,000 years just to count the stars in our own galaxy. And for every star you counted, you would have to imagine planets. We used to think that planets were rare. We used to think that our solar system was a special exception. But thanks to missions like the Kepler Space Telescope, we now know that planets are as common as dust. Most stars have planets. Many have rocky worlds orbiting in the habitable zone, that sweet spot where temperatures allow for liquid water to exist. If we are conservative, extremely conservative, and assume that only 1 in a billion stars has a planet capable of supporting life, that would still leave hundreds of Earth-like worlds in our galaxy alone. But the data suggests the number is far, far higher. There could be billions of habitable worlds in the Milky Way, and the Milky Way is just one island in an ocean. We know, thanks to the Hubble Space Telescope and the new James Webb Space Telescope, that there are at least 2 trillion galaxies in the observable universe. 2 trillion galaxies. Multiply 2 trillion by hundreds of billions of stars, and the numbers become meaningless to the human brain. They become just a sound, a vibration in the air. We cannot grasp that kind of infinity, but we can feel it. We can feel the weight of it pressing down on us, making us feel small, but also making us feel connected to something grand. With so much space and so much time, 13.8 billion years of cosmic history, the question that the physicist Enrico Fermi asked in 1950 remains one of the most haunting questions in all of science. He was sitting at lunch with colleagues, discussing the possibility of extraterrestrial life, when he simply asked, "Where is everybody?" It is a simple question, but it cuts to the core of our existential loneliness. If the universe is so old and life is so probable, someone should have visited us by now. The galaxy is old enough that a spacefaring civilization could have colonized it 1,000 times over. Even moving at slow speeds, far slower than light, a civilization could spread from star to star, building outposts, mining asteroids, and gradually encompassing the entire Milky Way in a few million years. A few million years is a long time to us, but to the universe, it is the blink of an eye. The universe has been around for thousands of millions of years. So, where are they? Why is the sky silent? Why do our radio telescopes, which have been listening for decades, hear only the hiss of cosmic background radiation and the natural hum of dying stars? There are many answers to the Fermi paradox. Some are terrifying. They suggest that civilizations destroy themselves before they can reach the stars. They suggest that nuclear war, or climate collapse, or artificial intelligence gone wrong serves as a filter that stops life from spreading. These are the dark answers. But there is another answer, a gentler answer, an answer that suggests we are not alone, but that we are being deliberately left alone. This is the zoo hypothesis, proposed by the astronomer John Ball in 1973. It suggests that advanced civilizations exist, that they are watching us, but that they have chosen not to interfere. Just as we do not land a helicopter in the middle of a pristine rainforest to interview the uncontacted tribes living there. Perhaps the extraterrestrials do not land their ships on the White House lawn because they want to preserve us. They want to see how we develop. They want to see if we can survive our own adolescence. Or perhaps we are the experiment. Think about how we do science here on Earth. When we want to understand how a disease spreads, or how a society evolves, or how genetics work, we create controlled environments. We create petri dishes. We create computer simulations. We create nature reserves. What if Earth is a nature reserve? What if our solar system, with its single yellow sun and its orderly arrangement of planets, is a protected zone, a place where life is allowed to evolve naturally without the contamination of advanced technology or alien culture? This idea changes the silence of the night sky. It transforms the emptiness into a privacy screen. It means that the reason we have not seen them is not because they are not there, but because they are very, very good at hiding. And why wouldn't they be? If a civilization is millions of years ahead of us, their technology would be indistinguishable from magic. They could be observing us right now using physics we have not yet discovered. They could be watching us through the distortions of gravity or through the entanglement of quantum particles. They could be hiding their presence by cloaking the heat signatures of their worlds. We look for radio waves because that is what we use. We look for Dyson spheres, giant structures built around stars to harvest energy, because that is what we think we would build. But we are like the ants looking for pheromone trails, while the humans above them are using smartphones and satellites. We are looking for the wrong things. Let us pause for a moment and consider the age of the universe again. 13.8 billion years. Our solar system formed about 4.6 billion years ago. That means there were 9 billion years of cosmic history before our sun even ignited. 9 billion years where other stars were born, lived, and died. 9 billion years where other planets cooled and oceans formed. 9 billion years where life could have started. If a civilization began just 1% of the universe's age before us, they would be 138 million years ahead of us. Look at how far humanity has come in just 10,000 years. We went from stone tools to walking on the moon. We went from painting in caves to splitting the atom. Now imagine what a civilization could do with 100 million years of science. They would not just be travelers in the universe. They would be the gardeners of the universe. They would be the architects of reality as we know it. If such beings exist, they would view us with the same mix of curiosity and detachment that we view a culture of bacteria in a lab. They might wonder, will they learn to cooperate? Will they destroy their own biosphere? Will they unlock the secrets of the atom and use it for energy or for war? These are the variables of the experiment, and we are the subjects. But there is a feeling that comes with this hypothesis, a feeling that is not cold, but rather strangely comforting. If we are an experiment or a zoo, it implies that we are valuable. You do not study something you do not care about. You do not protect a nature reserve if the life inside it is meaningless. It suggests that our struggles, our art, our science, and our capacity for love are interesting to someone else. It suggests that in the vast, cold infinity of space, we matter. We are worth watching. The silence of the universe might be the silence of a library or a nursery, a place where quiet is maintained so that learning can happen. And what are we learning? We are learning to be a planetary civilization. We are learning the hard lessons of stewardship and survival. Perhaps the test is not whether we can build faster spaceships, but whether we can build a sustainable world. Perhaps the aliens are waiting for us to pass a threshold of maturity before they reveal themselves. This brings us to a profound realization about the nature of contact. We often imagine that first contact will happen when we receive a signal from deep space, a pattern of prime numbers pulsing through the radio static. But if the zoo hypothesis is correct, first contact will happen when we are ready. It will happen when the experiment has concluded, or when the subjects have evolved enough to join the observers. Until then, we are left with the mystery. We are left with the evidence of our own existence and the peculiar parameters of our world. Think about the moon. Our moon is anomalously large compared to our planet. It stabilizes our orbital tilt, giving us regular seasons. It creates the tides, which may have been crucial for life moving from the oceans to the land. Without the moon, Earth might not be habitable. Is it just a coincidence that we have such a perfect celestial partner? Or consider the position of Jupiter. The giant of our solar system acts as a shield, its massive gravity catching comets and asteroids that might otherwise smash into Earth and wipe out all life. Is that just luck? Or is it design? These are questions that dance on the edge of science and philosophy. We call it the anthropic principle, the idea that the universe appears fine-tuned for life because if it weren't, we wouldn't be here to notice it. But the zoo hypothesis adds a layer of intention to that fine-tuning. It asks, what if the fine-tuning was done by hand? Not necessarily the hand of a god in the religious sense, but the hand of a Type 3 civilization, a society capable of harnessing the energy of entire galaxies. The gap between what we know and what is possible is where the wonder lives. We have only explored a tiny fraction of our own solar system. We have sent probes to the planets, yes. Voyager 1 and Voyager 2 have crossed the heliopause, leaving the magnetic bubble of our sun and entering the interstellar medium. They are our first ambassadors, carrying golden records with the sounds of Earth, whales singing, thunder crashing, people saying hello in 55 languages. They are like messages in bottles thrown into the largest ocean imaginable. Voyager 1 is traveling at 38,000 miles per hour. At that speed, it will take 40,000 years to drift near another star. 40,000 years. That is 4 times longer than human civilization has existed. The distances are a prison, but they are also a protection. They ensure that we cannot leave our cradle until we have mastered the physics of the cosmos. And they ensure that no one can come to us unless they have mastered levels of energy and time that we can barely conceive. So, as we sit here on our blue marble, spinning at 1,000 miles an hour, orbiting the sun at 67,000 miles an hour, drifting through the Milky Way at 500,000 miles an hour, we can feel a sense of safety in the isolation. We are hidden in the spiral arm of a galaxy that is just one of trillions. We are drifting in a quiet corner of the cosmos. And maybe, just maybe, that quiet is an artificial construct, a partition wall erected to give us the space to grow. As you go to sleep tonight, think about the ants in the garden. Think about how busy they are, how important their lives feel to them. And then pull your mind back, up into the sky, past the clouds, past the moon, past the orbits of Mars and Jupiter. Drift out into the silence between the stars. Imagine the gaze of something ancient and patient resting upon our little world, not with malice, but with curiosity, waiting to see what we will become. The universe is full of mysteries, and perhaps the greatest mystery is that we are here to solve them. We are the universe waking up. We are the part of the experiment that has become self-aware. And the journey to understand who is watching us and why is only just beginning. There are clues hidden in our DNA, in the mathematics of our physics, and in the very fabric of space-time itself. Clues that suggest reality is not exactly what it seems. The universe is a place of violent extremes, a canvas painted with fire and ice, where the laws of physics play out on a scale that creates and destroys worlds with equal indifference. If you were to choose a random point in the cosmos to exist, the odds are overwhelming that you would die instantly. You might find yourself in the crushing blackness of an intergalactic void, where the temperature hovers just a few degrees above absolute zero, and the nearest atom is light years away. You might materialize inside the searing plasma of a star, where temperatures reach millions of degrees, and matter is stripped of its electrons. You might be pulled apart by the tidal forces of a black hole, or blasted by the radiation of a supernova. Most of the universe is hostile to life as we know it. Most of the universe is a chaotic storm of energy and radiation. And yet, here you are. You are sitting or lying down in a room that is a comfortable temperature. You are breathing a mixture of nitrogen and oxygen that is perfectly balanced to sustain your metabolism. You are shielded from the deadly radiation of space by a magnetic field generated deep within the Earth's core. You are bathed in the gentle light of a yellow dwarf star that has burned with remarkable stability for billions of years. Is this just luck? Is it a cosmic accident that out of all the possible configurations of matter and energy, we find ourselves in a paradise? Or is this the first clue that the environment has been prepared for us? To understand the possibility that we are part of an experiment, we must look closely at the laboratory itself. We must examine the walls of our cage, which are not made of glass or steel, but of gravity and orbital mechanics. When astronomers first started discovering planets around other stars, exoplanets, they expected to find solar systems that looked like ours. They expected to find small rocky planets close to the star and large gas giants further out, all orbiting in neat, nearly circular paths. This is what we see when we look at Mercury, Venus, Earth, and Mars, followed by Jupiter, Saturn, Uranus, and Neptune. It is an orderly clockwork mechanism, a system of such precision that we can predict eclipses thousands of years into the future. But what we found out there in the galaxy was shocking. We found hot Jupiters, gas giants massive enough to swallow 1,000 Earths, orbiting their stars closer than Mercury orbits the Sun, whipping around in days or even hours. We found planets with highly elliptical orbits, swinging wildly from freezing cold to scorching hot, sterilizing any potential life on their surfaces. We found chaotic systems where planets had been ejected into the darkness of interstellar space. Our solar system appears to be an anomaly. It is strangely tidy. It is strangely calm. Jupiter, our massive protector, sits at just the right distance to act as a gravitational vacuum cleaner, sweeping up dangerous asteroids and comets that would otherwise bombard the inner planets. If Jupiter were closer, it would have disrupted the orbit of Earth, perhaps flinging us into the Sun or out of the system entirely. If it were smaller, it would not have been able to shield us from the debris left over from the formation of the solar system. The arrangement seems almost too perfect, like furniture placed carefully in a room to maximize comfort and safety. In the context of a cosmic experiment, this arrangement takes on a new meaning. It looks less like a random roll of the dice and more like a controlled variable. If you were designing a habitat for a delicate species, you would clear away the debris. You would install a shield. You would regulate the temperature. You would ensure that the primary energy source, the star, was stable. And our sun is remarkably stable. Many stars in the galaxy are red dwarfs, smaller and cooler than the sun. These stars are the most common type in the Milky Way, making up about 75% of the stellar population. For a long time, scientists thought red dwarfs might be good places to look for life because they burn their fuel so slowly that they can shine for trillions of years. But we have learned that red dwarfs are temperamental. They are prone to violent flares, unleashing torrents of X-rays and ultraviolet radiation that can strip the atmosphere off any planet orbiting nearby. If Earth orbited a red dwarf, life might have been sterilized a dozen times over. Our Sun, a G-type main sequence star, is rare by comparison. It is brighter, hotter, and crucially, much quieter. It provides a steady, unwavering light that has allowed photosynthesis to drive the food chain of our planet for billions of years without interruption. It is the perfect grow lamp for a planetary garden, but the coincidences do not stop at our solar system. We must look at our location in the Milky Way itself. Just as there are habitable zones around stars, regions where water can exist as a liquid, there is a galactic habitable zone. If we were located too close to the galactic center, the density of stars would be too high. We would be constantly buffeted by radiation from neighbors, and the gravitational influence of passing stars would destabilize our Oort cloud, sending showers of comets raining down on Earth. We would be too close to the supermassive black hole at the galaxy's heart, Sagittarius A, a monster 4 million times the mass of the Sun that occasionally flares with lethal energy. If we were located too far out, on the rim of the galaxy, there would not be enough heavy elements, metals like iron, silicon, and magnesium, to form rocky planets. The outer edges of galaxies are mostly hydrogen and helium, the primordial gases. You cannot build a human being, or a computer, or a planet like Earth out of just gas. You need the ashes of dead stars. We exist in the Goldilocks zone of the galaxy, the suburbs, if you will. We are far enough from the dangerous, crowded city center to be safe, but close enough to the element-rich regions to have the materials necessary for life. We are nestled in the Orion Spur, a minor arm of the galaxy, quietly drifting between the major spiral arms. This location offers us something else, something that might be part of the experiment's design. A clear view. Because we are not in a dense cluster of stars, our night sky is transparent. We can see out into the deep cosmos. We can see other galaxies. We can measure the cosmic microwave background radiation. If we lived in the center of a globular cluster, or inside a dense nebula, the sky would be a blinding wall of light, or an impenetrable fog. We would never know the universe existed beyond our immediate surroundings. We would be trapped in an illuminated room with no windows. But we have windows. We have a universe that seems to invite observation. This brings us to a profound philosophical implication of the zoo hypothesis. If we are an experiment, the experimenters have given us the tools to understand our situation. They have placed us in a universe that is decipherable. The laws of physics seem to be constant across space and time. Gravity works the same way here as it does in the Andromeda Galaxy, 2.5 million light-years away. The speed of light is a universal speed limit that binds everything together. Mathematics, the language of logic, describes the orbit of a planet and the vibration of an atom with equal precision. Why should the universe be understandable? Why should a species of evolved primates, who spent millions of years just trying to find fruit and avoid predators, have brains capable of understanding quantum mechanics and general relativity? It is possible that intelligence is the goal of the experiment. It is possible that the observers are waiting to see if we can figure it out, if we can deduce the rules of the game. Consider the moon again. I mentioned earlier that it stabilizes our axis, but there is another coincidence involving the moon that is purely visual. The sun is about 400 times larger than the moon, but the sun is also about 400 times farther away from Earth than the moon is. This means that from the surface of Earth, the sun and the moon appear to be almost exactly the same size in the sky. This is what allows for total solar eclipses, those breathtaking moments when the moon perfectly covers the disk of the sun, revealing the solar corona, the sun's tenuous outer atmosphere. These eclipses have been profound for human history. They have inspired awe, terror, and scientific discovery. It was during a solar eclipse in 1919 that astronomers were able to verify Einstein's theory of general relativity by observing how the sun's gravity bent the light of distant stars. If the moon were a little smaller or a little farther away, this perfect alignment would not happen. Is it just a geometric accident? A roll of the cosmic dice? Or is it a signpost? A little Easter egg left by the designers to say, "Look here, pay attention, there is physics to be learned." When we talk about aliens or advanced civilizations, we often project our own desires and fears onto them. We imagine them as conquerors or saviors. But a civilization capable of setting up a planetary experiment would likely be beyond such simple motivations. They would be akin to gods in their capability, but perhaps more like scientists in their temperament. They would be patient. They would value data. and the data they are collecting might be sociological. How does a civilization navigate the Great Filter? The Great Filter is a concept in the study of the Fermi paradox that suggests there is some barrier, some challenge, that prevents life from becoming widespread. Maybe life starts often, but rarely becomes complex. Maybe intelligence evolves often, but destroys itself with technology. Maybe civilizations become quiet and inward-looking rather than expanding outward. If Earth is a zoo, then we are currently approaching one of the most critical phases of the experiment. We have unlocked the power of the atom. We have built global communication networks. We are changing the climate of our planet. We are on the verge of creating artificial intelligence that might surpass us. The observers would be watching this moment with intense interest. This is the test. This is the moment where the subject either proves it is viable or fails. It is a fragile time. We feel the anxiety of it in our daily lives, the sense that things are accelerating, that the stakes are getting higher. But if we view this through the lens of the zoo hypothesis, that anxiety transforms into a sense of purpose. We are not just stumbling in the dark. We are taking a test that has perhaps been taken by millions of worlds before us. The silence of the universe is not an empty silence. It is the hushed silence of an exam room. The proctors are present, but they cannot help us. We have to solve the problem ourselves. The scale of this potential experiment is what generates the feeling of wonder that is so essential to our experience of the cosmos. It forces us to look at our history not as a series of wars and politics, but as the gestation of a planetary mind. We are the neurons of Earth connecting with one another, and the universe is waiting for us to wake up fully. The distances between stars, those vast empty gulfs that seem so lonely, are actually the quarantine zones that keep the experiment pure. If we could easily hop to Alpha Centauri, which is 4.3 light-years away, we might contaminate other experiments. We might bring our immaturity to worlds that are not ready for it. The speed of light limit ensures that we stay in our playpen until we have learned to walk without breaking things. And yet, despite the isolation, we are connected to the cosmos by the very matter of our bodies. The carbon in our DNA, the calcium in our bones, the iron in our blood, all of it was forged in the hearts of ancient stars that exploded billions of years ago. We are literally made of the debris of the laboratory. We are stardust that has come together to ask, where did I come from? This connection is physical, but it feels spiritual. It feels like belonging. Even if we are an experiment, we are an experiment made of the same holy stuff as the observers. We share the same physics. We inhabit the same reality. Let your mind drift back to the image of the garden. The ants go about their work, unaware of the complexity of the world above them. But occasionally, an ant might stop. It might sense the vibration of a footstep. It might catch a scent that does not belong to the garden. It might feel in some primitive way that there is something more. We are that ant. We are looking up at the great silence and sensing the footstep. We are seeing the perfect geometry of the eclipse and smelling the scent of design. We are beginning to suspect that the garden is not all there is, and this suspicion is the first step toward graduation. It is the first step toward lifting our heads and meeting the gaze of the gardener. The night sky is a tapestry of ancient light. The photons hitting your eyes when you look at the Andromeda galaxy have been traveling for 2.5 million years. They left their source before humans existed. They traveled through the void while ice ages came and went, while empires rose and fell, and they arrive now, tonight, to be caught by your retina. It is a personal connection across deep time. It is a gentle touch from the past, and in that light there is information. There is the signature of elements, the redshift of expansion, the story of gravity. The universe is constantly whispering its secrets to us. The zoo hypothesis suggests that we are finally learning to listen. It suggests that the experiment is not just about survival, but about understanding. About whether a collection of atoms can organize itself into a mind that comprehends the universe that created it. As we continue this journey of discovery, we must look even closer at ourselves. If the environment is the cage, then what is the subject? What is the nature of life itself? Is our biology purely the result of random mutation and natural selection? Or are there codes hidden within us, messages written in the four-letter alphabet of DNA that we have not yet deciphered? If a civilization wanted to track its experiment, where would it put the tracking device? Not in a satellite that could be destroyed, or a monolith on the moon that could be missed. They would put it inside us, in the self-replicating molecules that have carried the flame of life for 4 billion years. The next chapter of our mystery lies not in the stars, but in the microscopic universe within our own cells. The deeper we look, the more the boundaries between the observer and the observed begin to blur. We are the mystery we are trying to solve. The quiet of the cosmos is a mirror. It reflects our own questions back to us. And as we stare into that mirror, we begin to see that we are not alone in the dark. We are held in a vast, invisible hand that has shielded us from the chaos, warmed us with a steady star, and given us a world of breathtaking beauty. Whether that hand is chance or design, the result is the same. We are here. We are alive. And we are wondering. That is a miracle worth celebrating as we drift through the infinite sea of stars safe in our blue boat, sailing toward a destiny that is written in the light of the ancient sky. The journey continues inward to the code of life and outward to the signals that might be passing through us right now, carrying the conversations of giants who watch and wait. Imagine for a moment that you are walking through the ruins of an ancient library. The roof has collapsed long ago, allowing the stars to shine down on the dusty shelves. The scrolls are brittle, the ink is fading, and the language in which they were written is forgotten. You pick up a fragment of parchment. You cannot read the words, but you can feel the intent behind them. You can feel that someone, thousands of years ago, tried to save a thought, a memory, a piece of knowledge from the erasing wind of time. They encoded their mind onto physical matter, hoping that, one day, someone like you would pick it up and understand. Now, look at your own hand. Look at the skin covering your palm, the blue veins branching beneath the surface like rivers seen from space. You are holding something far more ancient and far more complex than any library on Earth. You are holding a message. Inside every single one of the 37 trillion cells that make up your body, there is a molecule about 2 meters long, coiled and folded into a space smaller than the point of a needle. This is deoxyribonucleic acid, DNA. It is the most efficient information storage system in the known universe. If you could take all the data in the world right now, every digital photo, every email, every movie, every book, every song, every line of code on the internet, and store it in DNA, it would fit into a teaspoon. That is not a metaphor. That is the raw storage density of the molecule that builds you. 1 gram of DNA can theoretically hold 215 petabytes of data. This incredible density raises a question that whispers at the edge of biology and cosmology. Is this molecule just a random accident of chemistry? Or is it technology? Is it a storage device designed by an intelligence so advanced that their engineering is indistinguishable from nature? If the zoo hypothesis is true, if we are part of a cosmic experiment or a protected sanctuary, then the cameras watching us might not be satellites in the sky. They might be encoded in the very instructions that knit our bones and beat our hearts. To understand why this is a possibility, we must look at the timeline of life on Earth. It is a timeline that bothers some scientists because it is uncomfortably tight. The Earth formed about 4.5 billion years ago. For the first few hundred million years, it was a hellscape of molten rock, constantly bombarded by asteroids and comets left over from the formation of the solar system. This period is called the Hadean Aeon, named after Hades, the underworld. The surface was sterilized over and over again. The oceans boiled away. Nothing could survive. And yet, the fossil record and chemical evidence suggest that life appeared almost the instant the planet cooled down enough for liquid water to remain stable, around 3.8 to 4 billion years ago. Life was already here, complex, self-replicating life. This rapid appearance is puzzling. Evolution, as we understand it, is a slow, grinding process of trial and error. It takes time for random chemical reactions to accidentally create a molecule that can copy itself. It takes even longer for that molecule to build a protective membrane, a metabolism, and a genetic code. If life is a random accident, it is like winning the lottery the very first time you buy a ticket. It is possible, but it is suspicious. This suspicion led one of the greatest scientific minds of the 20th century, Francis Crick, the man who won the Nobel Prize for co-discovering the double helix structure of DNA, to propose a theory called directed panspermia. Crick looked at the complexity of the genetic code, at how it is perfectly standardized across all life on Earth, from the bacteria in a deep-sea vent to the eagle soaring in the sky. And he wondered if it was too perfect to have evolved here from scratch. He suggested that perhaps life did not start on Earth. Perhaps it started somewhere else, on a world much older than ours, where it had billions of years to evolve and perfect itself. And then, an advanced civilization, realizing their star was dying, or simply wanting to spread the gift of life, loaded the seeds of biology onto spaceships. Not spaceships carrying astronauts, because living beings are fragile and space is vast and deadly, but spaceships carrying the ultimate travelers, bacteria, microbes, the hardiest forms of life, frozen in suspended animation, protected inside shielded canisters, shot out into the galaxy in all directions like dandelion seeds blowing in the wind. Directed panspermia suggests that Earth was one of the lucky planets where a seed landed. The canister opened, the bacteria multiplied in the primordial oceans, and the experiment began. If this is true, then we are not just observers of the universe. We are the descendants of aliens. We are the result of a colonization effort that began billions of years before the first human looked up at the moon. It implies that the aliens we are looking for are not strangers. They are our distant ancestors, or at least our creators. And the evidence for this might be hidden in the strange resilience of life itself. Consider the tardigrade, the water bear. It is a microscopic animal found in moss and lichens. It is cute in a strange way, but it is also indestructible. You can boil it, you can freeze it to absolute zero. You can expose it to the crushing pressure of the deep ocean. You can even expose it to the vacuum of space and the full blast of solar radiation. It simply curls up into a ball, dries out and waits. When conditions get better, you add water, and it wakes up as if nothing happened. Why would a creature evolve on Earth to survive the vacuum of space? Evolution only selects for traits that are necessary for survival in the current environment. There is no natural environment on Earth that requires an animal to survive in a vacuum or endure radiation levels found only in deep space. Unless, of course, the ancestor of the tardigrade was designed to travel through space. Unless its toughness is a leftover trait from the journey here. It is like finding a spacesuit in the closet of a primitive tribe. It suggests a history that has been forgotten. The tardigrade might be the ultimate astronaut, a biological machine built to survive the long, cold voyage between stars. But there is another layer to this mystery, one that is even more profound. If DNA is a storage medium, could it contain a message? Not just the instructions for building a body, but an actual message, written in the code itself? In 2013, two physicists from Kazakhstan, Vladimir Shcherbak and Maxim Makukov, published a paper with a provocative title, The Wow Signal of the Terrestrial Genetic Code. They applied information theory to the genetic code, the mapping between DNA and amino acids, and claimed to find patterns that were statistically impossible to occur by chance. They found symmetries, decimal notations, and logical structures that looked like an artificial language. They hypothesized that there is a biological SETI signal embedded in our cells, a stamp of authenticity, a signature. Imagine a manufacturer who puts a serial number inside a product. The serial number does not affect how the product works. It just identifies where it came from. Shcherbak and Makukov suggested that our genetic code contains a similar stamp. It is a message that says this life was created, or perhaps property of. This idea transforms our bodies into sacred texts. It means that while we are building radio telescopes to listen to the hiss of the galaxy, the message we have been waiting for has been inside us the whole time, replicating every time a cell divides, passing from generation to generation, waiting for us to become smart enough to read it. It would be the ultimate time capsule, a message that cannot be eroded by wind or water because it is alive, a message that grows and adapts and survives. This perspective shifts the feeling of the zoo hypothesis from one of being watched to one of being cherished. If a civilization went to the trouble of seeding the galaxy, of protecting the spark of life against the cold dark, then life must be incredibly precious to them. Perhaps they are lonely. Perhaps they are the only ones, and they are trying to ensure that the universe does not become a graveyard when they are gone. We might be their legacy. We might be the backup drive for a civilization that perished billions of years ago. The information in our DNA might contain not just the blueprint for a human, but the cultural history, the science, and the art of a lost world, compressed and encrypted, waiting for the decryption key. And the key might be our own technological maturity. Think about how we treat endangered species. We create gene banks. We freeze samples of DNA in vaults like the global seed vault in Svalbard, buried deep in the Arctic ice. We do this because we want to save the biological information in case of a catastrophe. Maybe the entire Earth is a Svalbard vault for the galaxy. Maybe we are the repository of life for this sector of the Milky Way. This would explain why we are left alone. You do not disturb the vault. You do not open the freezer door every day to check on the samples. You let them sleep. You let them stay safe until they are needed. The silence of the aliens is the silence of a guardian who knows that the best way to protect the treasure is to keep it hidden and undisturbed. And what a treasure it is! The complexity of a single human brain is greater than the complexity of any star in the universe. A star is just a ball of gas collapsing under gravity. It is big, but it is simple. Your brain has 100 billion neurons, each connected to thousands of others, creating a network of trillions of connections. It generates consciousness, love, fear, mathematics, and poetry. It is the most complex structure matter has ever formed. If the universe is an experiment to see what matter can do, then the human brain is the current high scorer. It is the masterpiece. The observers, if they are out there, must be looking at our capacity to feel and to think with a sense of immense satisfaction. They see matter that has learned to name itself. But there is a darker, or perhaps more pragmatic, possibility within the zoo hypothesis related to our biology. What if we are not the point of the experiment? What if we are just the carrier? In the history of Earth, humans have only been around for a blinking instant. Bacteria have ruled this planet for billions of years. They are everywhere, in the soil, in the air, in the deepest oceans, and inside our bodies. We have more bacterial cells in our bodies than human cells. From the perspective of a cosmic biologist, Earth is a planet of bacteria. Humans might just be a convenient way for bacteria to move around, to build spaceships, and to eventually spread to other planets. We might be the bus that the real citizens of Earth are riding. This is a humbling thought. It reminds us that our ego, our sense of being the center of the story, might be an illusion. The experiment might be about the resilience of life in its simplest forms, and we are just a complex byproduct, a glorious accident that happened because the bacteria needed a way to get off the rock. However, let us return to the feeling of the message, the idea that there is a code waiting to be read. As we learn to edit genes with tools like CRISPR, as we learn to design synthetic life, we are getting closer to the level of the designers. We are becoming the architects. This is a dangerous threshold. In many science fiction stories, this is the moment the aliens intervene. When the subjects start hacking the simulation, when the children find the matches. But in the gentle version of the zoo hypothesis, this is the moment of graduation. This is when the parents reveal themselves. You have figured out the code, they might say. You understand how difficult it is to build a living world. Now, you are ready to talk. The silence of the cosmos, then, is a waiting game. It is a pause in the conversation while the younger sibling learns to speak the language. And the language is not English or Chinese or binary. The language is biology. The language is physics. The Rosetta Stone is us. Every time you look in the mirror, you're looking at an ancient artifact. You're looking at a vessel that has carried a flame through 4 billion years of storms, asteroid impacts, ice ages, and plagues. You are the current captain of that vessel. The observers are watching to see if you can keep the flame lit. They are watching to see if we can transition from being a species that fights over land and resources to a species that understands its cosmic heritage. Imagine the patience required to run an experiment that lasts billions of years, to watch a planet cool, to watch the first oceans form, to watch the first single-celled organisms divide, to wait millennium after millennium as fish crawl onto land, as dinosaurs rise and fall, as mammals scurry in the undergrowth. The beings who watch us must operate on a time scale that we cannot comprehend. To them, Our lives are like the flashes of fireflies in the night, brief, bright, and beautiful. But the collective light of our civilization, the total output of our struggle to understand, that is a beacon. It is a signal that the experiment is yielding results. As you breathe in and out, feeling the rhythm of your own body, remember that this rhythm is part of a chain that has never been broken. Your heart beats because your parents' hearts beat, and their parents' hearts beat, all the way back to the first pulse of life in the primordial soup. You are connected to the beginning of time. And if the Panspermia theory is correct, you are connected to the stars, not just poetically, but genealogically. You are an alien on your own planet, or rather, the planet is a colony, and you are the colonist who has forgotten where they came from. The homesickness we sometimes feel when we look at the stars, that strange longing for a place we have never been, might be a cellular memory, a faint echo of the journey our ancestors took to get here. The universe is vast, cold, and mostly empty, but in the pockets of warmth, in the gravity wells of yellow stars, the universe is dreaming. It is waking up. We are the eyes of the cosmos. And if there are other eyes watching us, then we are not alone in the dark. We are part of a community of dreamers, separated by distance, but united by the mystery of existence. The experiment continues. The data is being collected, and the results are still uncertain. But the very fact that we can ask the question, that we can formulate the hypothesis, suggests that we are doing well. We are showing promise. We have explored the cage of the solar system and the code of our bodies. But there is another variable in this grand equation, one that is, perhaps, the most difficult to grasp. It is the variable that turns the impossible into the inevitable. It is the variable that allows mountains to turn into sand and stars to turn into iron. It is the variable of time. Time is the ocean in which the experiment floats. And to understand the zoo, we must understand the terrifying, beautiful depth of that ocean. We must understand how a civilization could exist for long enough to watch us evolve. We must look at the calendar of the cosmos. Time is the most invisible and yet the most crushing force in the universe. We measure it in heartbeats, in the rotation of our planet, in the orbit of our world around the sun. We celebrate birthdays, we mark anniversaries, and we worry about being late for appointments. But our concept of time is a local illusion, a biological convenience that allows us to function in a world of short-lived consequences. To the universe, a human life is not even a flicker. It is a quantum fluctuation that appears and vanishes before the fabric of space-time can even register a ripple. If we are to understand the zoo hypothesis, if we are to truly grasp the mind of the entity that might be watching us, we must abandon our human clocks. We must learn to tell time by the decay of protons and the birth of galaxies. We must enter the cathedral of deep time, where 1,000,000 years is merely a single tick of the second hand. To help us visualize this abyss, the astronomer Carl Sagan created the cosmic calendar. Imagine that the entire history of the universe, all 13.8 billion years of it, is compressed into a single Earth year. The Big Bang, that moment of blinding singularity when time and space erupted into existence, happens at the first second of January 1st. For the first few months of this cosmic year, there is no Earth, no Sun, no Milky Way as we know it. There is only the cooling of the primordial plasma, the formation of the first atoms, and the ignition of the first stars, which burn hot and blue and die quickly in violent supernovae. These explosions seed the cosmos with the heavy elements, the carbon, the oxygen, the iron, that will eventually make up your blood and bones. moons. But for now, they are just dust drifting in the dark. In this calendar, our galaxy, the Milky Way, does not form until May. Our sun, a latecomer to the party, does not ignite until the end of August. Think about that. 2/3 of the history of the universe has already passed before our solar system even exists. The Earth forms in early September. Life begins in late September, starting as simple, single-celled organisms floating in the warm oceans. And then, for months, nothing much happens. October passes, November passes. Life remains microscopic, simple, and silent. It is not until mid-December that complex life explodes in diversity. The dinosaurs, those ancient rulers of the planet who seem so distant to us, appear on Christmas Day and roam the Earth until December 30th. They rule for 160 million years, which is just 5 days in the cosmic year. And where are we? Where is humanity in this grand timeline? We appear on December 31st at 11:52 p.m., all of recorded history. Every king, every war, every invention, every poem, every religion, from the stone axes of the Paleolithic to the smartphone in your pocket, happens in the last 10 seconds of the last minute of the last day. We are the very last paint stroke on a canvas that has been being painted for a year. This perspective is humbling, but it is also terrifying. It shows us how fragile we are. It shows us that civilizations can rise and fall in the blink of a cosmic eye. But for the zoo hypothesis, this perspective is crucial. It suggests that if an advanced civilization arose even a few weeks earlier in the cosmic year, say in October or November, they would be billions of years ahead of us. A civilization that is 1 billion years old would not view time the way we do. To them, the rise and fall of a species like ours might be a seasonal event, like the blooming of wildflowers in spring. They would have the patience of stones. They would have the ability to wait for eons to see how an experiment plays out. When we ask, why haven't they contacted us? We are acting like a child who plants a seed and digs it up 10 minutes later to see if it has grown. We are impatient because our lives are short. But the observers, protected by their technology and perhaps by their mastery of biology, might be effectively immortal. They can afford to wait. They can afford to let the silence stretch out for millions of years because, to them, 1 million years is just a quiet afternoon. This brings us to the famous Drake equation, a formula used to estimate the number of active, communicative, extraterrestrial civilizations in the Milky Way galaxy. It multiplies several variables: the rate of star formation, the fraction of stars with planets, the number of habitable planets, the likelihood of life, the likelihood of intelligence, and the likelihood of communication. We have gotten very good at estimating the astronomical numbers. We know there are billions of planets, but the last variable in the equation, AL, stands for the length of time a civilization releases detectable signals into space. This is the bottleneck. This is the variable that determines whether the galaxy is full of voices or full of ghosts. If L is short, if civilizations tend to destroy themselves with nuclear weapons or environmental collapse within a few centuries of inventing radio, then the galaxy is a graveyard. We might be the only ones awake right now, surrounded by the ruins of worlds that didn't make it. But if L is long, if a civilization can survive its technological adolescence and live for millions or billions of years, then the galaxy should be teeming with them. The zoo hypothesis assumes that L can be very long. It assumes that there are survivors. It assumes that there are societies that have solved the problems of energy, war, and death. And if they have solved these problems, their primary motivation would shift from survival to stewardship, from conquest to curiosity. Imagine a being that has seen stars born and die, Imagine a consciousness that has watched galaxies collide. What would interest such a being? Not resources. They can harvest energy from stars and matter from asteroids. They have no need for our water or our gold. What would interest them is novelty. What would interest them is the unpredictable chaos of a young, struggling civilization. In a universe that is largely governed by the predictable laws of physics, life is the wild card. Evolution is the engine of surprise. We are interesting precisely because we are unstable. We are interesting because we don't know if we are going to make it. To an immortal observer, Earth is a drama, a reality show, a unique unfolding of potential that can never be exactly replicated. This perspective changes the nature of the great silence. It is not an empty silence. It is a respectful silence. It is the silence of a librarian watching a reader discover a book for the first time. It is the silence of a parent watching a child take their first steps. If they were to intervene, if they were to land their ships and give us their technology, they would destroy the very thing that makes us valuable. They would short-circuit our evolution. We would become just a pale imitation of them, rather than becoming ourselves. The gift of silence is the gift of self-determination. It is the gift of time to make our own mistakes and find our own answers. But time in the universe is not just a straight line. It is warped by gravity and velocity. Einstein taught us that time is relative. A clock near a black hole ticks slower than a clock floating in empty space. A traveler moving near the speed of light ages slower than a person staying at home. This is time dilation. It is a proven fact of physics, verified by our GPS satellites every single day. For a sufficiently advanced civilization, time dilation could be a tool. They could manipulate the flow of time to skip over the boring parts of history. They could place themselves in stasis or orbit a black hole, allowing millions of years to pass in the outside universe while only days pass for them. They could be time travelers moving forward into the future, checking on their zoos at intervals that seem short to them, but are eons to us. This might explain why we don't see them. They might be sleeping. They might be waiting for the interesting moments. From their perspective, the entire history of humanity might be a brief flash of activity that triggers a sensor, waking them up to take a look. Ah, they might say, the bipeds on the third planet have discovered nuclear fission. Let's see if they blow themselves up. This sounds cold, but it is merely a difference in scale. We do not mourn the death of a single skin cell. Yet that cell had a life. The observers might view civilizations as cells in the body of the galaxy. Some live, some die. But the whole continues. There is also the concept of deep time as a filter for truth. Over long enough timescales, lies cannot survive. Unstable systems collapse. Only truth, only stability, only harmony with the laws of nature can endure for 1 billion years. If the aliens are out there, they are not just technologically advanced. They are ethically and philosophically advanced. They have had enough time to outgrow the petty conflicts that plague us. They have had enough time to understand that domination is a short-term strategy, while cooperation is a long-term strategy. The zoo hypothesis implies that the galaxy is run by the wise, not the strong. It implies that the peace of the night sky is a genuine peace, enforced by the patience of those who have seen it all. However, we must also consider the terrifying power of entropy. The second law of thermodynamics states that the universe is gradually winding down. Disorder increases. Stars burn out. Energy dissipates. Eventually, in the far, far future, the universe will enter the heat death, where all stars are dark, all black holes have evaporated, and the cosmos is a cold, empty soup of particles. This is the ultimate fate of everything. A civilization that understands this would view life and complexity as precious resistance against the dying of the light. Every planet that teems with life is a fortress against entropy. Every mind that thinks and creates is a victory against the void. In this light, the Earth is not just a zoo, it is a seed bank for the future of the universe. We are being preserved because we carry the spark of complexity. The observers know that the stars will eventually go out. They know that the era of life is limited, so they cherish it. They watch over it with a melancholy appreciation for its fleeting beauty. They know that we are temporary, just as they are temporary in the grandest scheme. This shared mortality across vast gulfs of time connects us. We are all passengers on the same ship, sailing toward the end of time. The difference is that they have been sailing for a long time, and we have just come aboard. Consider the light of the stars you see tonight. Some of those stars are already dead. The light has taken so long to reach us that the source has burned out. We are looking at ghosts, but conversely, there are stars being born right now, deep in nebulas like the Orion Nebula, whose light will not reach Earth until long after humanity is gone. We are trapped in a sliver of now, sandwiching between a past we can only see as light and a future we will never know. The observers, however, might have a view that encompasses much more of the river of time. They might see the trajectory of our sun, the drift of our continents, and the evolution of our species as a single fluid motion. To them, we are not static beings. We are a process, a becoming. And what are we becoming? That is the question of the experiment. Evolution does not have a goal. It does not aim for intelligence. It aims for survival. But once intelligence emerges, it takes the reins. We are now steering our own evolution. We are curing diseases, extending our lifespans, and merging with our machines. We are beginning to think about leaving our planet. This transition from biological evolution to technological evolution is likely a universal marker. It is the moment a species graduates from the zoo to the wider community. But it is a dangerous transition. It is the moment where we have the power of gods, but the wisdom of apes. The observers are watching to see if we can acquire the wisdom before the power destroys us. The cosmic calendar is still turning. We are in the first few seconds of the new cosmic year. The future stretches out before us, vast and unwritten. If we can survive the next century, if we can navigate the great filter, we might have a future that lasts for millions of years. We might become the ancient ones. We might become the observers. One day, 1 billion years from now, our descendants might look down at a primitive world, watching a new species struggle to build a fire, and they will feel the same protective silence that is currently surrounding us. They will remember their own infancy. They will remember the time when they thought they were alone in the dark. So, when you feel the pressure of time, when you feel that your life is rushing by too fast, remember the stars. Remember that you are part of a story that is so long, so epic, and so slow that it requires a different kind of heart to appreciate it. You are a moment of consciousness in a universe that has waited 13.8 billion years for you to arrive. Do not rush. The universe is not in a hurry. The silence is not an absence of life. It is an abundance of time. It is the deep breath of the cosmos, holding its space for you to exist. But as we drift through these eons of time, contemplating the patience of the watchers, we must ask ourselves, how do they watch? if they're not landing on the White House lawn, if they are not sending radio signals, how are they monitoring the experiment? Is it possible that their technology is so advanced that it is invisible? Is it possible that the natural phenomena we see around us are actually their instruments? We must turn our gaze from the calendar of time to the structure of reality itself. We must look for the glint of the camera lens in the fabric of space. We must ask if the physics we study is the cage they built. Any sufficiently advanced technology is indistinguishable from magic. This is perhaps the most famous of Arthur C. Clarke's 3 laws, but we often forget its corollary. Any sufficiently advanced extraterrestrial intelligence is indistinguishable from nature. When we look for evidence of the zookeepers, we look for the things we would build. We look for metal ships with blinking lights. We look for Dyson spheres, megastructures that completely enclose a star to harvest its energy. We look for radio beacons beeping out prime numbers. But this is a failure of imagination. It is like a beaver looking for a dam made of sticks and mud, and failing to recognize that the Hoover Dam is also a structure built by intelligence. The Hoover Dam does not look like a beaver dam. It looks like a mountain of concrete. To the beaver, it is just a strange geological formation. If a civilization is 1 billion years ahead of us, they would not use metal and radio. They would manipulate the fundamental fabric of reality. Their technology would be seamless, silent, and invisible. It would look like the laws of physics themselves. Consider the concept of the von Neumann probe, proposed by the mathematician John von Neumann. This is a theoretical spacecraft that is capable of self-replication. It travels to a nearby star system, mines raw materials from asteroids or moons, and builds copies of itself. These copies then travel to other stars and repeat the process. The mathematics of exponential growth are staggering. Even if the probes traveled at a fraction of the speed of light, a single von Neumann probe could colonize the entire Milky Way galaxy in a few million years. Since the galaxy is over 10 billion years old, this should have happened thousands of times over. So, where are the probes? The zoo hypothesis offers a chillingly elegant answer. They are here. But they are not the size of spaceships. They are the size of bacteria, or perhaps the size of molecules. We are entering the age of nanotechnology, where we can build machines on the scale of atoms. A civilization 1 billion years ahead of us would have mastered this eons ago. Their cameras might be clouds of smart dust drifting in our upper atmosphere, analyzing the chemical composition of our air, monitoring our radio transmissions, and watching the lights of our cities turn on at night. They could be microscopic sensors embedded in the asteroid belt, powered by the faint light of the sun, dormant until they receive a specific wake-up signal. To us, they would look like dust. They would look like background noise in our data. We would breathe them in and never know. This idea of invisible observation forces us to reconsider our definition of privacy. We tend to think of privacy as walls and curtains, but in a universe teeming with advanced technology, privacy might be an illusion. The very atoms of our world could be recording devices. The concept of the Watcher is ancient in human mythology. Angels, spirits, gods who see everything. It is fascinating that our scientific speculation has circled back to this same archetype. The difference is that the angels are now self-replicating nanobots, and the gods are biological entities who have evolved beyond the need for bodies. The result is the same. We are never truly alone. The experiment is always running. The data is always being streamed. But let us look bigger. Let us look at the cage itself. I mentioned earlier that the speed of light, 186,000 miles per second, is the universal speed limit. Nothing with mass can travel faster than light. This limit is often seen as a tragedy by science fiction fans because it makes interstellar travel incredibly difficult. It locks us in our solar system. Even at the speed of light, it would take 4 years to reach the nearest star and 100,000 years to cross the galaxy. But what if this limit is not a bug in the code of the universe, but a feature? What if the speed of light is the bars of the zoo? If you wanted to run a simulation or an experiment with billions of different civilizations, you would need to keep them apart. You would need to prevent them from contaminating each other before they were ready. You would need a quarantine mechanism. The speed of light is the perfect quarantine. It ensures that a civilization cannot leave its home star until it has mastered immense energies and, presumably, the wisdom to use them. It ensures that war cannot spread easily across the galaxy. An invasion fleet cannot surprise a neighbor if it takes 10,000 years to get there. The speed of light creates pockets of causality, isolated islands where evolution can play out undisturbed. To an observer, the speed of light is the glass wall of the terrarium. It keeps the subjects in, and it keeps the predators out. And then there is the mystery of dark matter. When astronomers measure the rotation of galaxies, they find something impossible. The stars at the edge of the galaxy are moving too fast. There is not enough visible matter, stars, gas, dust, to hold them in orbit with gravity. By all rights, the galaxies should fly apart. But they don't. Something is holding them together, something invisible, something that makes up 85% of the mass of the universe. We call it dark matter, but that is just a placeholder name, for we have no idea what this is. It interacts with gravity, but it does not emit, absorb, or reflect light. It passes right through the earth and right through your body, as if you weren't there. Is it possible? And this is purely speculative, a what-if designed to stretch your mind. That dark matter is the infrastructure of the observers. If you were a Type 3 civilization capable of engineering galaxies, would you live on unstable, fragile planets made of baryonic matter, normal stuff? Or would you build your civilization out of something more permanent? Would you upload your consciousness into a substrate that does not interact with radiation, that is immune to supernovas, that is invisible to the primitive eyes of biological life? Dark matter could be a shadow biosphere, a vast invisible ocean of consciousness that exists right on top of us. We are the fish swimming in the water, unaware of the birds flying in the air above us. We occupy the same space, but we do not interact. The zoo might not be a place. It might be a phase of matter. We are the low-frequency matter, and they are the high-frequency matter. This would explain the Fermi paradox instantly. Where is everybody? They are right here. They are the gravity that holds our galaxy together. They are the unseen scaffolding of the cosmos. We are looking for radio waves, which are primitive ripples in the electromagnetic field, while they are communicating using gravitational waves or dark sector interactions. We are shouting with smoke signals, and they are using fiber optics. The silence is not a lack of communication. It is a lack of compatibility. We are simply not tuned to the right frequency yet. But even within our own solar system, there are hiding spots, places where a probe could sit for millions of years without being detected. These are the Lagrange points, 5 points in space, where the gravitational pull of the Earth and the Sun cancel each other out. An object placed at a Lagrange point stays put, orbiting in lockstep with the Earth. These are the parking lots of the solar system. We have started sending our own satellites there. The James Webb Space Telescope sits at L2, but what if something was already there? In the 1990s, astronomers searched for co-orbital objects at these points and found nothing large, but a sentinel, a probe the size of a toaster, coated in vantablack, a material that absorbs 99.9% of light, would be invisible. It could be watching us right now, beaming its monthly report to a receiver in the Alpha Centauri system. There have been moments where we thought we caught a glimpse of the machinery. In 2017, an object swept through our solar system on a trajectory that proved it came from deep space. It was named Oumuamua, Hawaiian, for scout. It was long and thin, like a cigar or a shard of rock. It was tumbling, and, most strangely, it accelerated as it left the solar system, pushed by something other than gravity. The consensus is that it was a strange comet, outgassing hydrogen that we couldn't see. But for a brief moment, the scientific community held its breath. Was this a derelict probe? Was this a piece of space junk from a galactic empire? The Harvard astronomer Avi Loeb argued passionately that we should consider the artificial hypothesis. Even if Oumuamua was natural, it showed us that interstellar objects do pass through our system. It proved that the walls of our solar system are porous. Things get in, and if a rock can get in, a probe can get in. The physics of the cage also includes the arrow of time. We remember the past, but we cannot see the future. This seems obvious to us, but in the equations of physics, time is symmetric. Most equations work just as well backwards as forwards. The fact that we are locked in a one-way flow of time is a deep mystery called the arrow of time, related to entropy. Could this too be a constraint of the simulation? If we could see the future, the experiment would be ruined. We would stop making choices. We would become actors following a script. The blindness to the future is what gives us free will, or at least the illusion of it. It is what makes our choices matter. The observers need us to be blind so that our behavior is authentic. If we knew we were being watched, if we knew the outcome, we would stop struggling. And the struggle is the point. This brings a sense of poignancy to our isolation. We are alone in the dark, armed only with our wits and our fragile bodies, facing a universe that seems indifferent. But it is precisely this isolation that gives our existence meaning. If the sky were filled with ships, if the aliens landed tomorrow and gave us the cure for cancer and the secrets of fusion energy, we would be saved, yes. But we would also be diminished. We would become pets. We would never know what we could have achieved on our own. The silence of the zookeepers is a form of tough love. It is a vote of confidence. They are betting that we can figure it out. They are betting that the monkeys who learn to use tools can eventually learn to master the stars. The physics as a cage metaphor extends to our own biology. We are trapped in bodies that require oxygen, water, and a very specific temperature range. We are tethered to this planet by our frailty. We cannot just walk out into the cosmos. We have to build shells, spaceships, to carry our bubble of Earth with us. This physical limitation forces us to be clever. It forces us to cooperate. You cannot build a spaceship alone. You need a civilization. You need an economy. You need a history of engineering. The difficulty of space travel is a filter that ensures only unified planetary civilizations can leave their cages. A species that is constantly at war with itself will never muster the resources to build a starship. It will burn its resources on bombs and eventually die in its crib. So, The cage is also a test of character. The bars are made of distance and radiation, and the key is cooperation. The observers are waiting to see if we can stop fighting long enough to fit the key in the lock. They are watching our wars with what I imagine is a mixture of horror and pity, knowing that every missile we fire is a step backward, a delay in our graduation. But they are also watching our international space stations, our global treaties, and our internet with hope. These are the signs that the organism is trying to heal itself. These are the signs that the subject is becoming intelligent. And what happens if we pass the test? What happens if we finally build a ship that can cross the light years? Or if we finally decode the signal in the noise? The zoo hypothesis suggests that the cage will open. The quarantine will be lifted. We will be invited into the Galactic Club. This is a staple of science fiction, but it is also a plausible sociological outcome. If the galaxy is old, the club is already there. They are just waiting for us to pay our dues. And the dues are paid in survival. They are paid in the wisdom earned through thousands of years of mistakes. As you look around your room, consider that the air you breathe, the light you see, and the gravity that pulls you down might all be calibrated parameters. The universe feels natural, but a well-designed zoo always feels natural to the animals. The best exhibits are the ones where the fences are hidden in the landscaping. We are living in a masterpiece of design, a habitat so perfect that we think we own it. But we are guests. We are temporary residents in a structure that was built long before we arrived and will persist long after we are gone. The invisible nature of the technology surrounding us, the potential dark matter observers, the nanobots in the dust, the quarantine of light speed, creates a feeling of sublime paranoia. It is the feeling that there is more to the picture than we can see. But instead of fear, let it fill you with curiosity. Let it drive you to learn more physics, to look deeper into the microscope, to stare harder at the stars. Because if we are being watched, the best way to get the attention of the watchers is to be interesting. The best way to end the silence is to say something worth hearing. And we are just learning to speak. The physics of our universe are the rules of the game. We are the players, and somewhere beyond the veil of the vacuum, beyond the curve of space-time, the game designers are watching the scoreboard. They are watching to see if we can solve the puzzle of how to survive ourselves. The next piece of that puzzle is not found in the atoms or the stars, but in the strange, intangible network that connects us all. The evolution of our own consciousness. For the true barrier to the stars is not the speed of light. It is the darkness in our own minds. The most dangerous thing in the universe is not a black hole, nor is it a supernova. It is a mind that has not yet learned to master itself. We have spent the last few chapters looking outward at the stars, at the physics of the cage, and at the biology of our bodies. But if the zoo hypothesis is true, if we are indeed subjects in a cosmic experiment, then the most critical variable is not our technology, but our consciousness. The observers are not just watching our rockets. They are watching our ethics. They are watching how we treat each other. They are watching to see if a species that evolved from tribal primates can transcend its biological programming and become a planetary civilization. This transition from a fractured collection of warring tribes to a unified, peaceful world is likely the hardest step in the evolution of any intelligent species. It is the step where most fail. It is the step where the silence of the universe finds its most tragic explanation. The silence of the graveyards. To understand this test, We must look at where we are on the scale of cosmic civilizations. In 1964, the Soviet astronomer Nikolai Kardashev proposed a scale to measure a civilization's technological advancement based on the amount of energy it can harness. A Type 1 civilization can use all the energy available on its home planet, solar, wind, geothermal, and the energy of the atom. They can control their weather, they have ended scarcity, and they live in equilibrium with their biosphere. A Type 2 civilization can harness the total energy of its star, perhaps by building a Dyson swarm, a vast cloud of solar collectors orbiting the sun. They are immune to extinction. If their planet is destroyed, they can live in space. A Type 3 civilization controls the energy of an entire galaxy. They are the gods of physics, capable of moving stars and engineering space-time. Where are we? We are not even Type 1. We are, according to Carl Sagan's calculation, a Type 0.7 civilization. We do not control our planet's energy. We burn dead plants, coal and oil, that were buried millions of years ago. We are dependent on finite resources. We are still fighting over lines on a map. We are like a toddler who has found a loaded gun. We have discovered nuclear weapons, capable of destroying our civilization in an afternoon. But we have not yet developed the political maturity to ensure they are never used. We have created the Internet, a global nervous system that connects us all, but we use it to spread misinformation and hatred as much as we use it for knowledge. This disconnect between our power and our wisdom is the great filter. The great filter is a concept that suggests there is a barrier in the development of life that is extremely difficult to cross. It is a hurdle that wipes out almost everyone who attempts it. Some scientists think the filter is behind us. Perhaps the origin of life itself was the hard part, but the zoo hypothesis suggests the filter is right in front of us. The filter is us. The test is whether we can survive our own adolescence without burning down the house. If the galaxy is full of watched worlds, then the observers know exactly what happens to civilizations at our stage. They have seen it 1,000 times. They have seen worlds that turned into radioactive wastelands. They have seen worlds where artificial intelligence enslaved its creators. They have seen worlds that consumed their biosphere and collapsed into famine and dust. This is why they do not land. This is why the Prime Directive, the fictional Star Trek rule that forbids interference with primitive cultures, is likely a real universal law. Imagine if a Type 2 civilization landed on Earth tomorrow. Imagine if they gave us the technology for unlimited energy and faster-than-light travel. What would we do with it? Would we use it to explore the stars in peace? Or would we build weapons that could destroy suns? Would we export our wars, our racism, and our greed to the rest of the galaxy? We are not ready. Giving a warp drive to humanity in its current state would be like giving a flamethrower to a chimpanzee. It is not an act of kindness. It is an act of negligence. The quarantine is in place to protect the galaxy from us. But there is hope. The experiment is not over. We are showing signs of awakening. There is a phenomenon reported by astronauts that suggests our brains are capable of a profound shift in perspective. It is called the overview effect. When a human being leaves the surface of the Earth and looks back at our planet from orbit, something changes in their mind. They see a fragile blue ball hanging in the endless black void. They see a thin, glowing line of atmosphere, the only thing shielding all of life from death. They do not see borders. They do not see nations. They see one system, one home, one people. Edgar Mitchell, the Apollo 14 astronaut who walked on the moon, described it as an explosion of awareness. He said, You develop an instant global consciousness, the people orientation, an intense dissatisfaction with the state of the world, and a compulsion to do something about it. This shift is the seed of Type 1 consciousness. It is the realization that we are all crew members on the same spaceship. If the zookeepers are watching for a signal that we are ready to graduate, this is it. They are not waiting for a radio transmission of prime numbers. They are waiting for the overview effect to become the default state of the human mind. They are waiting for us to stop identifying as Americans, or Russians, or Chinese, and start identifying as Earthlings. This evolution of consciousness is not just poetic, it is necessary for survival. The challenges we face, climate change, pandemics, nuclear proliferation, asteroid defense, are planetary problems. They cannot be solved by one nation alone. They require a planetary response. The pressure of these crises is forcing us to evolve. It is forcing us to build institutions like the United Nations, the World Health Organization, and the International Space Station. These are imperfect, clumsy attempts at planetary governance, but they are a start. They are the first neural connections of a global brain. The Internet, for all its flaws, allows an idea to travel from a student in Sweden to a farmer in India in a fraction of a second. We are becoming a noosphere, a sphere of thought enveloping the Earth. The observers would be monitoring this noosphere. They would be analyzing our data traffic, not to spy on our emails, but to measure the coherence of our collective mind. Are we becoming more empathetic? Are we reducing violence? The data suggests we are. Despite what the news tells you, we are living in the most peaceful time in human history. Rates of violent death have plummeted over the last few centuries. We have eradicated diseases like smallpox. We have cut extreme poverty in half. We are slowly, painfully, stumbling toward a more moral world. This progress is slow, and it is fragile, but it is real. It is the data that might save us from the delete button of the simulation. But let us consider the dark forest theory for a moment, just to contrast it with the zoo hypothesis. The dark forest theory suggests that the universe is a dark forest full of silent hunters, and the reason everyone is quiet is because it is dangerous to make noise. If you shout, you get eaten. This is a terrifying idea based on the assumption that all civilizations are driven by survival and fear. But the zoo hypothesis assumes something different. It assumes that advanced civilizations are driven by something higher than fear. It assumes that they have solved the problem of scarcity. If you have unlimited energy and can build anything from atoms, you do not need to steal your neighbor's land. You do not need to fear them. Game theory, the study of strategic decision-making, supports this. In a game that is played once, betrayal might be the best strategy. But in a game that is played repeatedly over millions of years, like the interactions between galactic civilizations, cooperation is the winning strategy. Aggressive civilizations are unstable. They create enemies. They expend energy on defense. Eventually, they are destroyed by a coalition of others, or they destroy themselves. Peaceful, cooperative civilizations are stable. They build alliances. They share knowledge. They endure. Therefore, the oldest civilizations in the galaxy, the ones running the zoo, are likely the most peaceful. They are the altruists. They are the gardeners, not the hunters. This implies that the Galactic Club is not a military empire, but a scientific and cultural union, a federation of minds that have survived their own great filters. If we are invited to join, it will be because we have proven that we can play by these rules. We have to prove that we can be trusted with the keys to the universe, And the test is happening right now in our daily lives. Every time you choose kindness over anger, every time you choose cooperation over competition, you are casting a vote for the survival of our species. You are moving the needle of the experiment. There is a concept in evolutionary biology called neoteny, the retention of juvenile traits into adulthood. Humans are neotenous apes. We look like baby chimps even when we are grown. We are playful, curious, and adaptable like children. Perhaps this is our superpower. Perhaps the observers value our curiosity. Older civilizations might become rigid, set in their ways, bored by their own omniscience. They might look at us with our chaotic art, our passionate music, our desperate striving, and see a spark of vitality that they have lost. We might be the new blood that the galaxy needs. Our very immaturity, which makes us dangerous, also makes us creative. We dream of things that a billion-year-old AI might consider impossible. But we must be careful not to romanticize our flaws. We are currently destroying the very biosphere that supports us. We are causing a mass extinction event, wiping out species at a rate not seen since the asteroid killed the dinosaurs. This is a major strike against us in the experiment. A Type 1 civilization does not destroy its own life support system. If the observers are guardians of life, they might be looking at us not with hope, but with growing concern. They might be debating whether to intervene, not to save us, but to save the whales, the forests, and the biodiversity of Earth from us. We might be the virus that the immune system of the planet is trying to shake off. This adds a sense of urgency to our situation. We are not just waiting for aliens to say hello. We are in a race against time to prove that we are worth keeping. The silence of the universe is a mirror reflecting our own behavior. If we destroy ourselves, the universe will not mourn. It will simply wait for the next intelligent species to evolve from the rats or the roaches, and the clock will reset for another 100 million years. The experiment will continue with new subjects. However, there is evidence that we are capable of profound change. Look at how quickly we addressed the hole in the ozone layer. In the 1980s, we realized that our chemicals were destroying the atmosphere. The world came together, signed the Montreal Protocol, and banned those chemicals. The ozone layer is healing. Look at how we avoided nuclear war during the Cuban Missile Crisis. We stared into the abyss and pulled back. We have the capacity for wisdom. We just need to exercise it more often. The zoo hypothesis also invites us to reconsider the nature of intelligence. We tend to think of intelligence as the ability to build rockets and computers. But perhaps true intelligence is the ability to live in harmony with your environment and your fellow beings. Whales have brains larger than ours. They have complex languages and social structures. They have lived in the oceans for millions of years without destroying them. Are they more intelligent than us? Maybe the observers are talking to the whales. Maybe the whales are the successful experiment, and we are the volatile control group. This is a humbling thought, one that strips away our human arrogance. As we gaze up at the Milky Way, knowing that there are likely billions of Earth-like planets out there, we must realize that we are not special because of our location or our biology. We are special only if we choose to be. We are special if we can navigate the treacherous path from animal to star traveler without losing our souls. The signal we are sending to the stars is not our radio waves. It is our culture. It is the sum total of our actions. Imagine a civilization that can capture the energy of a black hole. They could incinerate Earth from 1,000 light years away without us ever seeing the beam. But they don't. watch, they wait. This restraint is the ultimate proof of their civilization. It is the proof that power does not always corrupt, that absolute power over a long enough timeline might lead to absolute morality. The fact that we are still here, that we haven't been wiped out to make way for a hyperspace bypass, suggests that the universe is governed by laws of protection, not destruction. So, the next time you feel despair at the state of the world, remember the great filter. Remember that this struggle we are going through is normal. It is the growing pains of a planetary species. Every civilization in the sky has likely gone through this bottleneck. They have all faced their own nuclear standoffs, their own climate crises, their own moments of truth. The ones who are watching us are the ones who made it. They are the alumni of the School of Survival, and their silence is a form of encouragement. It is a sign that they believe we can make it too. The path forward is clear, though it is not easy. We must become a Type 1 civilization. We must harness the sun, stabilize our climate, and unify our people. We must stop acting like a collection of tribes and start acting like a crew. If we can do that, the cage will unlock, the quarantine will end. And we will take our place among the stars, not as conquerors, but as companions. The journey to the stars is not a technological journey. It is a spiritual one. The rocket is just the vehicle. The payload is our consciousness. And the destination is a universe where we are finally, truly awake. But as we strive for this awakening, as we look for the signs of our own maturity, we must also look for the physical remnants of those who came before. If the galaxy is billions of years old, it should be littered with ruins. It should be full of the archaeological debris of civilizations that failed or those that ascended. Where are the monuments? Where are the mega structures? Is it possible that we have already seen them, but simply failed to recognize them? Is it possible that the stars themselves are being engineered? We must now turn our attention to the anomalies, to the strange flickering of Tabby's star, to the unexplained voids in the cosmos, to the structures that defy natural explanation. We must ask if the landscape of the universe is actually a cityscape, built on a scale so grand that we have mistaken the architecture for mountains. We often walk through cities without noticing the infrastructure that makes them work. We walk over cables buried beneath the pavement. We ignore the cell towers disguised as trees, and we forget about the satellites silently orbiting overhead. We accept the environment as it is, assuming that the hills and the rivers are natural, even when they have been shaped by human hands for centuries. Now, lift your gaze to the galaxy. We assume that the stars are scattered randomly, that the voids between them are empty wilderness, and that the strange, flickering lights we see are merely natural phenomena we have not yet explained. But if the zoo hypothesis is true, if we are living in a managed preserve or a cosmic laboratory, then the galaxy is not a wilderness, it is a metropolis. And if we look closely enough, we should be able to see the scaffolding. We should be able to see the exhaust plumes of the engines that power the experiment. In 2015, a group of citizen scientists, ordinary people looking at data from NASA's Kepler Space Telescope, noticed something impossible. The Kepler telescope was designed to stare at one patch of sky, monitoring the brightness of 150,000 stars simultaneously. It was looking for planets. When a planet passes in front of a star, it blocks a tiny fraction of the light, causing a dip in brightness. For a planet the size of Jupiter, the dip is about 1%. For a planet the size of Earth, it is a microscopic 0.01%. The dips are regular, periodic, and predictable. But there was one star, catalogued as KIC 814X2852, that broke all the rules. This star, which sits about 1,470 light-years away in the constellation Cygnus, did not dip by 1%. It dipped by 22%. Imagine a light bulb in your room suddenly dimming by a quarter of its brightness and then flickering back on. A planet cannot do that. Even a star the size of our sun would only be dimmed that much if something half its own width passed in front of it. And the dips were not regular. They were chaotic. They lasted for days, sometimes weeks. The light curve looked like a jagged mountain range, not the clean U-shape of a planetary transit. The astronomer Tabitha Boyajian, who led the paper describing the anomaly, was baffled. The data was checked for errors. The telescope was checked for glitches. Everything was working perfectly. The star was really dimming. The scientific community scrambled for natural explanations. Was it a swarm of disintegrating comets? Unlikely, as there would need to be millions of them, all clustered together in a way that defied orbital dynamics. Was it a cloud of interstellar dust? Maybe, but dust glows in infrared light because it gets hot, and this star showed no excess infrared. Was it a variable star undergoing some unknown internal convulsion? Perhaps, but F-type stars like this one are known for being stable. Then another astronomer, Jason Wright, suggested a hypothesis that sent a shiver through the world. What if it is a megastructure? In 1960, the physicist Freeman Dyson proposed that a sufficiently advanced civilization, a Type II civilization on the Kardashev scale, would eventually need more energy than their planet could provide. They would need the entire output of their star. To get it, they would dismantle their planets and asteroids to build a vast swarm of solar collectors surrounding the star, a Dyson swarm. If such a structure were incomplete, or if it were composed of billions of giant panels orbiting in a chaotic cloud, it would block the starlight in exactly the way we observe with KIC Altum Tvimt Xit 2852. We might be looking at a construction site. We might be watching a civilization enclosing their star, turning off the lights to the outside world so they can power their unimaginable machines. If this is true, then KIC 8462852, now affectionately known as Tabby's star, is the first direct evidence of the zookeepers. It is a glimpse of the machinery behind the curtain. It suggests that the galaxy is being engineered. And it is not the only anomaly. Since the discovery of Tabby's star, astronomers have found other dippers, stars that exhibit similar, inexplicable behavior. There is a star called VVV Wit-Oit, which stands for "What is this?" that dimmed by 97% before returning to normal. Something massive, something opaque, something larger than a star eclipsed it. Was it a dark cloud? Or was it a fleet? The idea of alien megastructures changes our perception of the night sky. It transforms the stars from distant nuclear furnaces into potential power plants. It suggests that the energy of the universe is being harvested, and where there is harvesting, there is waste. A Dyson sphere captures visible light and converts it into useful work, but the laws of thermodynamics demand that waste heat be radiated away. This heat would appear as a glow in the infrared part of the spectrum. In the 1980s, the IRAS satellite scanned the entire sky in infrared, looking for these Dyson signatures. It found very few candidates. This was interpreted as a lack of advanced civilizations, but perhaps we are just looking for the wrong kind of heat. A truly advanced civilization might be so efficient that they waste almost nothing. They might run their computers at temperatures close to absolute zero, rendering their structures invisible to our thermal cameras. They might be stealth civilizations, hiding their footprint to avoid detection by predators or to avoid disturbing the wildlife in the zoo. But if a Dyson sphere is a structure we can barely imagine, there is something even larger that haunts the data of modern cosmology. It is not a presence, but an absence. When we look at the large-scale structure of the universe, we see a cosmic web. Galaxies are strung together in long filaments of light, surrounding vast, empty voids where almost nothing exists. These voids are usually tens of millions of light-years across. But in the direction of the constellation Boötes, there is a void that defies all logic. The Boötes void is a sphere of emptiness, nearly 330 million light-years in diameter. It is so huge that if the Milky Way were in the center of it, we would not have discovered other galaxies until the 1960s. We would have thought we were alone in an infinite darkness. In a region of space that size, standard cosmological models predict there should be at least 2,000 galaxies. In the Boötes void, we have found only 60. It is a ghost town. It is a hole in the universe. Astronomers call it the Great Nothing. Natural explanations suggest it formed from the merger of smaller voids, a random fluctuation in the density of the early universe. But there is a more unsettling possibility, one that aligns with the wildest speculations of the zoo hypothesis. What if the void is artificial? What if it is the territory of a Type 3 civilization, a galactic empire that has expanded across millions of light years? If a civilization were to harness the energy of not just one star, but millions, and if they were to wrap those stars in Dyson spheres to capture 100% of their output, the galaxies would vanish from the visible spectrum. They would go dark. As the civilization expanded, colonizing galaxy after galaxy, a bubble of darkness would grow outward. To a distant observer, it would look like a void. It would look like the galaxies were disappearing. The Boötes void is perfectly spherical, which is suspicious in a universe where gravity tends to create irregular shapes. Could we be looking at the glowing borders of an empire that has walled itself off from the rest of the cosmos? Or perhaps, could we be looking at a Garden of Eden that has been hidden from view? This theory is terrifying because of the scale. A civilization capable of darkening a region 300 million light-years across is effectively omnipotent compared to us. They are not just biological beings. They are a force of nature. If they are the ones running the zoo, then our entire galaxy is just a small exhibit in a much larger museum. We are like a single anthill in a nature reserve that spans a continent. The silence we hear is the silence of their cloaking technology. The darkness of the night sky is not empty space. It is the hull of their ship, and the evidence for vanishing is not limited to distant voids. Closer to home, inside our own galaxy, we have begun to notice that stars are disappearing. In 2017, a project called VASCO, Vanishing and Appearing Sources During a Century of Observations, began comparing photographic plates of the sky taken in the 1950s with modern digital surveys. They were looking for stars that existed 70 years ago, but are gone today. Stars do not just vanish. They explode as supernovae, leaving behind bright nebulas that last for thousands of years. Or they slowly fade as white dwarfs over billions of years. They do not just blink out. Yet, the VASCO team found hundreds of transients, lights that were there in the 1950s and are gone now. Some might be flaws in the old photographic plates, scratches, or dust. Some might be flaring red dwarfs that dimmed below visibility. But a small percentage remain unexplained. One moment, a star is there. 70 years later, nothing. No supernova remnant, no gravitational lens, just empty space. What could make a star disappear without a bang? A Dyson sphere could. If a civilization decided to complete their construction project, enclosing their star in a final shell of material, the light would go out. From our perspective, the star would vanish. Are we watching the lights of the galaxy being turned off, one by one? Are the neighbors closing their blinds? This phenomenon creates a feeling of profound unease, but also a strange excitement. It suggests that the galaxy is active. It suggests that we are not looking at a static painting, but at a bustling construction site where the workers are simply too far away to be seen. The missing stars might be the homes of the observers. They might be the control centers for the experiment. Consider the Fermi paradox again in this light. If the galaxy is full of disappearing stars and giant voids, then the paradox disappears. The aliens are not missing. They are everywhere. They are just incredibly good at energy management. They do not waste photons by letting them fly off into deep space for monkeys to look at. They harvest everything. The fact that we can see the stars at all might be the exception. We might be living in a wilderness preserve where the stars are allowed to shine naturally for aesthetic or scientific reasons. The visible universe is the zoo. The dark universe is the real civilization. There is another anomaly that hints at large-scale engineering, the alignment of the universe. When we look at the cosmic microwave background, the afterglow of the Big Bang, we expect it to be random. We expect the hot and cold spots to be scattered without any pattern. But we find strange alignments. There is a pattern called the axis of evil, a line that seems to divide the universe in a way that aligns with the plane of our own solar system. This shouldn't be possible. The structure of the early universe, formed 13 billion years ago, should have no knowledge of the orientation of the Earth, which formed 9 billion years later. Is this a statistical fluke, a trick of data processing? Or is it a hint that the universe we perceive is a simulation or a construct oriented around us? In a planetarium, the stars are projected onto a dome. The projector is aligned with the seats. If we are in a zoo, the background might be a projection. The axis of evil might be the seam in the wallpaper. This leans into the simulation hypothesis, but it overlaps with the zoo hypothesis. If you are building a habitat for a species, you orient the environment to their perspective. You make sure the sun rises in the east. You make sure the North Star stays fixed. The anomalies in the cosmic background might be the fingerprints of the architects on the walls of the reality they built. We also have the mystery of the great attractor. Our galaxy, along with thousands of others, is streaming through space at 1.3 million miles per hour towards a specific point in the sky. We are being pulled by an immense gravitational force. But when we look in that direction, we see dust, the zone of avoidance. The center of our own galaxy blocks the view. We know there is a massive cluster of galaxies there, the Norma cluster, but the mass doesn't seem to be enough to explain the speed at which we are moving. Something bigger is pulling us, a concentration of mass equivalent to tens of thousands of galaxies. Is it just a knot of dark matter, or is it a city, a central hub where the civilizations of the local supercluster congregate? We are drifting towards it like a raft caught in a current. We will not arrive for billions of years, but the pull is relentless. It reminds us that we are not stationary. We are cargo. We are being transported across the universe towards a destination we cannot see. The great attractor stands as a monument to the unseen forces that govern our fate. It is a gravitational lighthouse in the dark. These anomalies, Tabby's star, the Buddha's void, the vanishing stars, the axis of evil, the great attractor, are the cracks in the facade of a natural universe. They are the data points that don't fit the curve. A skeptic dismisses them as errors or natural phenomena we don't understand yet. And they might be right. Science demands that we exhaust every natural explanation before we claim aliens. But a dreamer looks at them and sees the outline of a story where we are surrounded by giants who are quietly going about their business, dismantling stars and rearranging galaxies, while we play with our radio sets and wonder if anyone is out there. The feeling this evokes is not insignificance, but rather a sense of being protected. If there are civilizations capable of moving stars, then the threats we fear, asteroids, supernovas, gamma-ray bursts, are manageable problems for them. They could deflect an asteroid with a whisper of gravity. They could damp down a dying star to keep it stable. The stability of our solar system for 4 billion years, the long period of boring billion years where life simply existed without being wiped out, might be due to their intervention. We might be living in a safe zone maintained by the same engineers who built the Buddha's void. As we continue to build better telescopes, as we launch the James Webb and the upcoming Nancy Grace Roman telescope, we will find more anomalies. We will find more stars that wink out. We will find more atmospheres with impossible chemical signatures. The resolution of our cameras is getting sharp enough to see the bars of the cage. And this brings us to a critical question. What happens when the subjects realize they are in a zoo? What happens when the ants figure out the garden is artificial? Do the keepers reveal themselves? Or do they reset the simulation? The history of human knowledge is a history of realizing we are not the center of things. We realized Earth is not the center of the solar system. We realized the sun is not the center of the galaxy. We realized the galaxy is not the center of the universe. Now, we are on the verge of realizing that the natural universe might not be natural at all. This is the final Copernican revolution. It is the realization that we are not even the authors of our own reality. We are characters in a book that is being written by someone else. But a character in a book can still be loved. A subject in an experiment can still be precious. The sheer scale of the engineering required to maintain a galaxy-sized zoo implies a level of dedication that borders on love. You do not build a Dyson sphere to protect a microbe unless that microbe is the most important thing in the world to you. We are looking at the evidence of care on a cosmic scale. The vanishing stars are the nightlights being turned off so we can sleep. The voids are the walls that keep the noise out. The anomalies are the proof that we are not forgotten. So, as you walk under the night sky, look for the dark patches. Look for the stars that flicker. They are not errors. They are the signature of the civilization that might be waiting for us to join them. The universe is a construction site, and we are the apprentices just beginning to learn how to hold a hammer. The blueprints are hidden in the physics, and the foreman is watching from the shadows. The next chapter of our story will take us beyond the physical evidence into the very nature of the mind that could conceive of such a plan. What kind of ethics, what kind of philosophy governs a species that can eat stars? During the Second World War, The indigenous people of remote islands in the Pacific Ocean witnessed something that shattered their understanding of reality. They saw giant silver birds descend from the clouds, roaring with the voice of thunder. These birds did not flap their wings, yet they flew. They landed on the beaches, and from their bellies emerged men with pale skin, dressed in strange green clothes. These men did not hunt, they did not fish, and they did not farm. Yet they possessed endless supplies of food, magical boxes that could speak with voices from the sky, and tools of steel that never broke. To the islanders, this was not technology. It was a miracle. It was a visitation from the gods. When the war ended and the soldiers left, the silver birds stopped coming. The cargo, the food, the medicine, the tools, disappeared. In a desperate attempt to bring the gods back, the islanders built life-sized replicas of the airplanes out of straw and bamboo. They carved headphones out of wood and sat in control towers made of palm fronds, waiting for the signal. They marched in formation, mimicking the soldiers, hoping that if they performed the ritual correctly, the sky would open up again. This phenomenon, known as a cargo cult, is a profound lesson in the danger of premature contact. The islanders were not stupid. They were simply exposed to a reality for which they had no context. The contact did not uplift them. It confused them. It destroyed their culture and replaced it with a hollow imitation of another. Now, project this tragedy onto a galactic scale. If a Type 3 civilization were to land on Earth today, hovering over our cities in ships the size of moons, manipulating gravity like we manipulate clay, what would happen to us? We would be the islanders. Our science, our religion, our philosophy, and our very sense of self would instantly crumble. We would stop inventing because their technology would make our efforts look like children playing with mud. We would stop dreaming because their reality would exceed our wildest dreams. We would become a cargo cult, worshiping the visitors, mimicking their behavior without understanding their wisdom. The human spirit, the drive to explore and discover, would be extinguished by the sheer weight of their superiority. This is the ethical core of the zoo hypothesis. The silence of the universe is not an act of abandonment. It is an act of mercy. It is the implementation of a cosmic prime directive, a rule that forbids advanced civilizations from interfering with the natural development of younger species. If the observers are truly wise, if they have survived for millions of years, they understand that knowledge cannot be given. It must be earned. They understand that the struggle to understand the universe is what builds the character of a civilization. If they gave us the answers to fusion energy or faster-than-light travel, we would not have the maturity to use them safely. We would be like the islanders with the cargo, using the tools of gods to fight the wars of men. The zoo is a quarantine zone established to protect our cultural immune system. But what kind of mind creates such a rule? We must try to imagine the psychology of a species that has conquered all physical needs. A civilization that can harvest the energy of stars has no need for conquest. They have no need for slaves, or gold, or water, or land. They can build 1,000 Earths from the debris of the asteroid belt. They can simulate 1,000,000 paradises in their computers. When survival is no longer the primary motivator, what is left? The answer is curiosity. The answer is beauty. The answer is the preservation of the unique. In a universe where they can build anything, the one thing they cannot build is surprise. They cannot build a history that they did not live. We are the surprise. We are the history. On Earth, evolution has taken a chaotic, winding path that has produced a species unlike any other. Our art, our music, our irrational love, our contradictory nature, this is unique data. To an immortal observer, the way we handle a pandemic, or the way we write a symphony, or the way we fall in love, is fascinating because it is authentic. It is not a simulation. It is raw, messy, biological life fighting for meaning in a cold universe. We are the wildlife in the cosmic park. And just as we protect the mountain gorillas not because they are useful to us, but because they are magnificent and rare, the observers might protect us simply because we are us. The value of humanity to a galactic empire is not our labor or our resources. It is our story. This perspective shifts the power dynamic. We often feel small and insignificant when we look at the stars. But if we are an experiment or a protected species, then we are precious. We are the rarest thing in the galaxy, a civilization in its larval stage, just beginning to dream. The observers might view us with a mixture of nostalgia and hope. They might look at our wars and remember their own ancient history. They might look at our primitive rockets and remember the first time they defied gravity. We are a living memory of where they came from. By watching us, they are reconnecting with their own origins. The zoo is a time machine for them, a way to witness the birth of consciousness over and over again. However, there is a deeper, more metaphysical layer to this psychology. A civilization that has existed for 1 billion years might have evolved beyond biology entirely. They might have merged with their machines, becoming a post-biological intelligence. They might exist as patterns of information floating in a cloud of nanobots, or as pure consciousness inhabiting the quantum foam of space-time. To such beings, the physical world of rocks and gas might seem heavy and slow. They might view biological life, us, with the same tender pity that we view a flower that blooms for only a day. They know that we are trapped in decaying bodies, trapped in the illusion of time, trapped in the suffering of separation. Their non-interference might be a form of spiritual discipline. They might know that suffering is a necessary catalyst for growth. On Earth, a butterfly must struggle to break out of its chrysalis. If you help it, if you cut the chrysalis open to save it the effort, the butterfly will die. Its wings will never be strong enough to fly. The struggle forces the fluid into the wings. The struggle creates the strength. The observers know this universal truth. They know that if they save us from our climate crisis or our nuclear standoff, we will never learn the collective responsibility required to be a stellar species. We must break out of our own chrysalis. We must push against the walls of the cage until we are strong enough to leave it. This does not mean they are indifferent. It means they are patient, and their patience is likely supported by a surveillance system so advanced that it borders on omniscience. In the previous chapters, we talked about nanobots and smart dust. But let us go further. Imagine a technology that can map the position of every neuron in your brain without touching you. Imagine a sensor that can read the electromagnetic field of your thoughts. If the observers have this capability, then they are not just watching our bodies. They are archiving our minds. Every thought you have, every dream, every memory might be backed up in a galactic database. This connects to the concept of the ancestor simulation. If a civilization is powerful enough, they could simulate the past with perfect fidelity. They could recreate Earth history to study it. Are we in the real universe, or are we in the simulation? From the inside, There is no way to tell, but the ethical implications are the same. If we are being watched, then our lives have an audience. The silence of the room is deceptive. The walls are listening. This can be a comforting thought, that nothing is truly lost, that every life is remembered. Or it can be a terrifying thought, that we have no privacy. But to a benevolent observer, privacy is less important than preservation. They are the librarians of consciousness, ensuring that no story is ever truly deleted from the cosmic record. There is also the possibility that the zoo is not a single cage, but a nursery for many species. We might be one of thousands of worlds currently being monitored. The Galactic Club might be waiting for a graduating class. This would explain why we see no one. The other civilizations at our level are also quarantined. The ones above our level are hiding. We are in a silent study hall, surrounded by other students we cannot see, all taking the same test. The test of survival, the test of kindness, the test of foresight. And the teachers are walking the aisles, invisible, checking our work, but never giving us the answers. Consider the dark forest theory again, but invert it. In the dark forest, everyone is a hunter. But what if the galaxy is a managed forest? A forest with rangers? A forest where the dangerous predators, the aggressive expansionist empires, are weeded out early? If the zookeepers are as powerful as we think, they would not allow a Borg-like civilization to consume the galaxy. They would prune the garden. They would stop the cancer before it spreads. This suggests that the reason we have not been invaded is that we are protected. There is a shield around our solar system, not made of energy, but made of policy, a do-not-touch sign that is respected by every advanced civilization in the Milky Way. We are safe, but we are also isolated. This isolation creates a specific psychological pressure on humanity. It forces us to look inward. It forces us to confront our own reflection. If we knew aliens were coming to save us, we would become lazy. If we knew aliens were coming to destroy us, we would become unified by fear. But knowing nothing, suspecting that we are alone, that forces us to take responsibility. It forces us to grow up. The silence is a mirror that reflects our own behavior back to us without distortion. And what happens when we finally look into that mirror and like what we see? What happens when we finally achieve planetary peace, sustainability, and a unified consciousness? The zoo hypothesis predicts a moment of first contact that is radically different from the movies. It won't be an invasion. It will be an invitation. It will be a subtle signal, perhaps a mathematical key sent to our computers, or a slight change in the orbit of a moon, or a holographic projection in the sky. A message that says, "You are ready. The quarantine is lifted. Welcome to the community." This moment, the graduation, is the ultimate goal of the experiment. It is the moment the child leaves the house. It is the moment the subject becomes a partner. And what will we bring to the table? We will bring our art. We will bring our music. We will bring the unique perspective of a species that evolved on a water world, that learned to love despite death, that learned to hope despite despair. We will bring the human element to a logic-driven, immortal machine mind. Our passionate, chaotic humanity might be the most valuable commodity in the universe. We are the poets of the galaxy. But until that day comes, we must live with the mystery. We must live with the great silence. And we must reframe it. Instead of seeing the silence as emptiness, see it as a held breath. See it as the quiet of a theater before the curtain rises. The audience is out there in the dark, watching the stage of Earth. The play is in its third act. The tension is high. The protagonists us, are facing their greatest challenges. Will they destroy themselves? Or will they find a way to work together? The observers are leaning forward in their seats. They are rooting for us because they know that if we make it, the galaxy will be a little less lonely and a little more beautiful. As you stare at the moon tonight, remember that it might be more than a rock. It might be a sentinel. Remember that the silence is not indifferent. It is expectant. You are part of a story that is being told across billions of years. A story of matter waking up. A story of the universe trying to understand itself through your eyes. The experiment is ongoing. The data is flowing. And the most important variable in the equation is you. But as we contemplate the benevolent watchers, we must also ask a harder question, a question that challenges the very nature of benevolence. Is a zoo, no matter how nice, still a prison? Is a protected sanctuary, no matter how safe, still a limit on our potential? What if we want to leave before we are ready? What if we try to break out? We must now turn our attention to the edges of our cage, to the Voyager probes, to our radio broadcasts, and to the active attempts we are making to shout into the dark. We must ask, what happens when the ants start trying to climb the glass? For the past 100 years, Earth has been doing something that no other planet in our solar system does. It has been leaking. It has been bleeding invisible waves of energy out into the cold vacuum of space. Every television show, every radio broadcast, every radar ping from a military base, and every cellular phone call has generated a faint ripple in the electromagnetic field. These ripples travel at the speed of light, expanding outward from our planet in a perfect sphere that grows larger by 186,000 miles every single second. This sphere is now about 200 light years across. It contains thousands of stars, and inside that sphere, the silence of the natural universe has been replaced by the chaotic, buzzing, contradictory noise of humanity. If the zoo hypothesis is true, if there are keepers watching us from the quiet of the dark, then, for the last century, the animals have been banging on the glass. We have been shouting. And the question is, has anyone heard us? Imagine an alien astronomer on a planet orbiting the star Vega, which is 25 light years away. If they have a radio telescope sensitive enough, and a civilization a billion years ahead of us certainly would, they are not seeing Earth as it is today. They are seeing Earth as it was 25 years ago. They are watching our sitcoms, listening to our pop music, and decoding our news reports from the turn of the millennium. But if they look further out, to the edge of the radiosphere, they are hearing the first weak transmissions of the 1930s. They are hearing the opening ceremony of the Berlin Olympics. They are hearing the voice of Adolf Hitler. It is a sobering thought that our first ambassador to the stars, the first voice to represent Earth to the galaxy, might be the voice of a dictator. This is the accidental message we have sent. A message of war, of comedy, of tragedy, and of noise. It is a raw, unfiltered data dump of the human condition. To a zookeeper, this noise is a critical threshold. It marks the moment a species becomes radioactive. It is the moment we become detectable, not just by our biology, but by our technology. Before radio, Earth was silent. We were just another biological world reflecting sunlight. After radio, we became a beacon, a lighthouse that strobes with the patterns of intelligent life. This transition is likely a major event in the experiment. It is the moment the subject wakes up and starts talking in its sleep. The observers would be analyzing this data with intense fascination. They would be building a cultural profile of humanity based on our broadcasts. I Love Lucy, the moon landing, the nightly news of wars and famines. All of it is data. All of it tells them who we are, and perhaps it tells them why we are still in the cage. But we have not just been leaking accidentally. We have also tried to shout on purpose. In 1974, from the Arecibo Observatory in Puerto Rico, humanity sent its first deliberate message to the stars. The Arecibo message was a powerful pulse of radio waves aimed at the globular cluster M13, 25,000 light-years away. It was a simple message consisting of 1,679 binary digits, ones and zeros. Why that number? Because 1,679 is a semi-prime number, divisible only by itself, 1 and 2 prime numbers, 23 and 73. This was a mathematical key. If an alien intelligence arranged the ones and zeros into a grid of 23 columns and 73 rows, a picture would emerge. A pixelated image of a human stick figure, the double helix of DNA, the atomic numbers of the elements of life, and a diagram of our solar system. It was a postcard, a declaration of existence. We are here. This is what we are made of. This is where we live. It was a gesture of profound optimism. We sent it to a cluster of stars so far away that the message will not arrive for 25,000 years. If anyone replies, the answer will not come back for 50,000 years. By then, humanity might be gone. Or we might have evolved into something unrecognizable. The Arecibo message was not a conversation. It was a monument. It was a shout into the canyon of eternity, just to hear the echo. But from the perspective of the zoo hypothesis, it was something else. It was the ants climbing to the highest blade of grass and waving a flag. It was a direct attempt to breach the quarantine. And then there are the physical messages, the bottles we threw into the cosmic ocean. In 1977, NASA launched the Voyager 1 and Voyager 2 spacecraft. Their primary mission was to explore Jupiter, Saturn, Uranus, and Neptune. They sent back breathtaking images of storms the size of Earth and moons covered in ice. But their secondary mission was eternal. Attached to the side of each spacecraft is a 12-inch phonograph record made of gold-plated copper. The Golden Record. It contains sounds and images selected to portray the diversity of life and culture on Earth. It has the sound of wind, of thunder, of birds, of whales. It has greetings in 55 languages. It has the brainwaves of a woman in love. It has music from Bach, Mozart, Chuck Berry, and Blind Willie Johnson. It has diagrams of our anatomy and maps to our location using pulsars, dying stars that act like cosmic lighthouses, as landmarks. Voyager 1 is now the most distant human-made object in the universe. It has crossed the heliopause, the boundary where the sun's wind gives way to the interstellar medium. It is sailing in the dark, 14 billion miles from home. It is moving at 38,000 miles per hour. But space is so vast that it will not come close to another star for 40,000 years. The Golden Record is a message in a bottle designed to last for 1 billion years, long after the pyramids have eroded to dust, long after Earth has been swallowed by the expanding sun. The Golden Record will still be intact, drifting through the Milky Way. It is a tombstone and a love letter. But is it safe? Is it wise to hand out a map to our house to strangers? This is the debate that divides the scientific community. The physicist Stephen Hawking warned against active SETI, the practice of intentionally sending signals to aliens. He argued that if aliens visit us, the outcome would be much as when Columbus landed in America, which did not turn out well for the Native Americans. He suggested that advanced civilizations might be resource nomads looking to conquer and colonize. By shouting, we are inviting a predator to our doorstep. We are ringing the dinner bell. This view aligns with the dark forest theory. The reason the universe is quiet is that everyone who shouts gets destroyed. However, the zoo hypothesis offers a different perspective on the danger. If we are already in a zoo, the keepers already know we are here. They built the cage. They know exactly where Earth is. Sending a map on Voyager does not reveal our location. It reveals our intention. It reveals our psychology. It shows that we are curious. It shows that we want to connect. It shows that we are proud of our music and our science. To a benevolent observer, the golden record is not a security breach. It is a piece of art. It is a child drawing a picture for their parents. It might be the very thing that convinces them we are worth saving. Look, they might say, they are trying to share their beauty. They are not just warriors, they are artists. The breakout attempt is not just about physical distance. It is about intellectual distance. Every time we point the James Webb Space Telescope at a distant exoplanet and analyze its atmosphere, we are peering through the bars. We are looking for the keepers. We are trying to catch them in the act of maintenance. If we find a planet with an atmosphere full of industrial pollutants, chlorofluorocarbons, or artificial isotopes, we will have found a technosignature. We will have found proof of another civilization, and that discovery would shatter the illusion of the zoo. It would force a confrontation. What happens when the subject of an experiment discovers the observer? In quantum physics, the act of observation changes the outcome. In sociology, it is called the Hawthorne effect. People behave differently when they know they are being watched. If humanity confirms the existence of aliens, our behavior will change instantly. The experiment will be compromised. We might stop developing naturally and start trying to mimic them, or we might panic. This is why the keepers must remain hidden. The prime directive depends on secrecy. But as our technology improves, secrecy becomes harder to maintain. We are building bigger telescopes. We are listening to broader frequencies. We are launching more probes. We are pressing our faces against the glass, staring into the dark, daring something to move. There is a daring proposal called the Solar Gravitational Lens Mission. Einstein predicted that gravity bends light. The sun is massive enough that its gravity can act as a giant magnifying lens. If we could send a telescope to a point 550 astronomical units away, about 50 billion miles, far beyond Pluto, we could use the sun's gravity to zoom in on the surface of an exoplanet. We could see continents. We could see cities. We could see the lights of an alien world. We are currently working on the technology to do this. If we succeed, we will strip away the privacy of the stars. We will be the ones looking into their zoos. This reversal of the gaze is a pivotal moment in the evolution of a species. It is the moment the child becomes an adult, the moment the observed becomes the observer. If the zoo hypothesis is true, the keepers must be anticipating this. They must have a protocol for first contact initiated by subject. Do they block our view? Do they create a hologram to fool us? Or do they accept that the game is up? Perhaps the test was never about waiting for them to call us. Perhaps the test was about whether we had the courage and the intelligence to find them. The desire to leave, to explore, to break out of the solar system is written into our DNA. We are a migratory species. We walked out of Africa to populate the continents. We sailed across oceans in wooden boats to find new islands. We flew to the moon just to see what it was like. We are now planning missions to Mars. This drive is relentless. It is an evolutionary imperative. A species that stays in one place eventually goes extinct. A localized catastrophe, a volcano, an asteroid, a plague, can wipe them out. But a multiplanetary species is robust. The zookeepers know this. They know that a successful civilization must eventually leave its cradle. So, the escape attempt is actually a graduation ceremony. When we launch a ship that can reach another star, a generation ship, or a warp drive, or a laser sail probe like the breakthrough Starshot project aims to build, we are handing in our final exam paper. We are saying, we have mastered the physics of the cage. We are ready to come out. The silence of the universe might persist until that very moment, until the moment our ship crosses the threshold of the solar system, not as a piece of drifting metal like Voyager, but as a piloted vessel under conscious control. Imagine the crew of that first interstellar ship. They would be traveling through the dark for years, perhaps decades. They would be the loneliest humans in history, but they would also be the most hopeful. They would be carrying the seed of Earth to a new soil, and if the zoo hypothesis holds, they might be the ones to meet the greeters. They might find, waiting for them in the darkness between stars, a station, a buoy, a welcome mat. Congratulations, the message might read. You made it. You didn't blow yourselves up. You didn't retreat into virtual reality. You came to find us. But there is a risk. There is always a risk. The risk that the dark forest is real. The risk that by shouting, by launching probes, by trying to leave, we are making a terrible mistake. The risk that the reason the galaxy is quiet is because something is hunting the noisy ones. This is the tension that sits at the heart of our exploration. It is the gamble of existence. Do we hide in the dark and survive as a quiet, lonely moss on a rock? Or do we light a fire and risk attracting the wolves in the hope of finding other travelers? Humanity has made its choice. We have lit the fire. We have sent the radio waves. We have launched the probes. We have chosen the path of curiosity over the path of fear. And perhaps that choice is the very quality the observers are looking for. Courage, the willingness to face the unknown. A civilization that hides forever is a dead civilization. A civilization that reaches out, even with trembling hands, is alive. The radiosphere expanding from Earth is a bubble of life in a vast ocean of entropy. It contains our music, our laughter, our tears, and our screams. It is a messy, beautiful, chaotic announcement. And somewhere, out there in the silence, a receiver just might be turning in our direction, tuning in to the strange new song coming from the third rock around the yellow sun. As Voyager 1 drifts further into the dark, carrying our golden greeting, it passes through the Oort cloud, the shell of icy debris that surrounds our solar system. It is entering the true interstellar void. It is a tiny, fragile machine, powered by a dying nuclear battery representing 7 billion souls. It is the ultimate act of faith. Faith that there is someone to hear us. Faith that the universe is not just a mechanism, but a community. And faith that when we finally climb the glass walls of our garden, we will find not a boot waiting to crush us, but a hand reaching down to help us up. The escape has begun. The signal has been sent. The ants are marching toward the stars, and the silence is about to be broken. In the final silence of the experiment, we find ourselves standing at the edge of a great cliff, looking out over an ocean of stars that seems to have no end. We have traveled from the microscopic code of our DNA to the megastructures of the galaxy. And yet, the most profound question remains unanswered. Why? If we are an experiment, what is the goal? If we are in a zoo, what is the lesson? The answer may lie in the realization that the universe is not just a place where things happen, but a process of awakening. We are the means by which the cosmos looks back at itself and asks, "Who am I?" For 13.8 billion years, the universe has been evolving, moving from simplicity to complexity. It began with hydrogen and gravity, and it has led to consciousness and love. This suggests that the zoo is not a prison, but a womb. The observers are not captors, they are midwives. They are waiting for the moment when we no longer need the cage because we have internalized the laws of the universe, when we realize that the atoms in our bodies are the same as the atoms in the stars. We are no longer separate. We are the universe, observing itself from within. This journey of understanding is an infinite path. Every discovery we make, every mystery we solve, only reveals a larger mystery waiting behind it. The discovery of the largest galaxy, ICLM-01, which stretches over 4 million light-years and holds 100 trillion stars, did not make us feel smaller. It made the universe feel grander. It showed us that the scale of creation is always bigger than our imagination, and if the universe can produce a monster of that scale, what other wonders are waiting for us when we finally leave our home? The experiment is not happening out there in the laboratory of the stars. It is happening in here, in the way we choose to perceive reality. If we choose fear, we stay in the cage. If we choose wonder, the cage becomes a gateway. The silence of the night sky is not a rejection. It is an invitation to keep looking up and to keep wondering. We are part of a community of explorers, some human, some perhaps ancient and alien, all united by the same curiosity about the mystery of existence. As you drift toward sleep tonight, let the scale of the cosmos wash over you. You are a momentary flash of consciousness in a universe that will last for trillions of years. But your thoughts, your questions, and your capacity for awe are the very things that give the universe meaning. You are star stuff that has learned to name the stars, and the observers, whoever and wherever they may be, are watching with a sense of immense pride, because the child is finally starting to recognize the Father's face in the patterns of the light. The experiment continues, the data is still flowing, and the most important discovery is yet to be made, the discovery of who we are when we are no longer afraid of the dark. Until that day, we keep our eyes on the heavens and our hearts open to the mystery. For we are not just subjects in a zoo. We are the heirs to an infinite kingdom of light.